I want to talk about how we would stretch or shrink a function. Now, the function that I'm choosing to use here is absolute value. So let me just explain the absolute value graph. The absolute value graph, it's designated with these vertical lines. This means the absolute value of x. Whatever is put in to this, the positive answer or positive version is returned. So for example, if I said, okay, x is 5 right here, x is 5, you see the y value is also 5. But if x were negative 5, or I put negative 5 in here, the absolute value returns positive 5. Positive 5 there as well. So no matter what you put in to the absolute value, you get the positive version out. So that's why it looks like this. It looks like the line, y equals x until it hits 0, and then it's reflected up here. Now, to stretch or shrink a function, the way that we do that is with a multiplier. So here's what I mean by that. If I were to take my absolute value and put like a 3 out front, it would just stretch it, make it kind of thinner, make it grow faster. If I were to do like a decimal, let's put a 0.5 out, a 1/2. You'd see it gets stretched. It doesn't increase as quickly. And I could even, do something like that, 0.1, see how kind of stretched out it gets. If I did, 2 versus 5, look how thin that thing gets. Now, that's usually a nice, easy concept to kind of think about is, okay, so if my number in front, let's just make it an A. If my number in front is larger than 1, it stretches vertically, it gets thinner, it grows faster. If my number in front is smaller than 1, it's kind of stretched out horizontally, it gets thicker, it grows slower. It's still growing, it's just growing slower than it did. I should just also mention that if that number in front were negative, we talked about this in another video, it reflects it over the x-axis. It makes my outputs all negative. Okay. Now, one thing that I just want to talk about is how we figure out what that is or how we can calculate values. Now, I just want you to notice here, and maybe I'll just highlight a value or two. If I say like x equals 1, I put that right here. And then I say, okay, no, x equals 2. You see that right here, okay? If I were to change that coefficient in front of my absolute value, let's just change it to 2. Let me show you what happens to my outputs. Notice that they doubled. It was 1, now it's 2. It was 2, now it's 4. It just doubled the outputs, okay? Now, if I were to instead, well, I meant to add that out front. Let me change this a little bit. If I were to make it 3 instead, put a 3, notice that it went from a y value of 1 to 3. It went from a y value of 2 to 6. It tripled the y values. So that's why it looks like it's being stretched vertically. The y values are just 3 times bigger than they were. We were stretched by a factor of 3. So now let's put a decimal in there instead. Instead of 3, let's put a 0.5, a 1/2. Okay. So you see the y value used to be 1, now it's 1/2. The y value used to be 2, now it's 1. It cut all of the y values in half. So this is how we can transform functions, stretch them, shrink, they kind of stretch them vertically or horizontally, and we can figure out what that factor is by saying, well, what happened to the y values? How much did those y values grow or shrink? So a simple multiplier in front will help us stretch the function. If the multiplier is larger than 1, it makes our graph appear thinner. It stretches it, we say, vertically. If that number in front is less than 1, as was the case here, then it stretches us horizontally. It makes it appear kind of thicker because it makes the y values grow slower. If this video helped you, please like and subscribe for more math help.